All right, the last type that we're going to learn how to use the reaction quotient, which is going to be Q, not E, but Q, when you have everybody has an initial value. Remember before we had some that had everybody had initial value, but they gave us a hint on equilibrium. That was one of our examples. They had given us H2 and N2 and ammonia, and then they gave us a hint about H2. So this is going to be when you have no hint and you have equilibrium numbers. Nobody's a zero. So in the beginning, nobody's a zero. So we're going to start this, and then I'm going to do some analogies with you. So we'll go down here. So you've got H2 plus I2 making 2HI. And it gives me the K for this reaction is 50. That's important. I'm going to put him over the side. So that means I'm going to have some X's in my table. I do know that. And so it says the following concentration are initial concentrations that we have 0.08 molar here. We have 0.06 molar here. And we have 0.79 molar here. I do know that one side's going to be adding, one side's going to be subtracting. I just don't know. Nobody's a zero. Do you understand? Nobody's a zero. So I don't know if I'm subtracting, adding, or subtracting and adding and adding. I don't know if this reaction is going forward or if it's going backwards. Okay? Before I knew it was going forward because somebody was a zero. Or I knew it was going forward because it gave me a hint at equilibrium. There's no hint. That's all it tells me. Okay? It just says find the numbers at equilibrium. So my analogy for you is most of you use your cell phones to get around nowadays. Okay? And so let's say you are trying to find how to get to someone's house. You've never been to a friend's house before, and you put their address in. Before your phone can give you any sort of directions, what does it need to do? It has to figure out where you are. And once it figures out where you are, it will tell you if you need to go forward or whether you need to go backwards. Okay? So that's my analogy. I'm going to use the analogy of your friend's house is number 50. And you need to figure out, are you at like house number 80 or are you at house number 20? Do you need to go forward or do you need to go backwards? So you need to figure out where you are in this reaction to see what this reaction needs to do. It's trying to get back to equilibrium, and it's going to react in a way so that it gets equilibrium is like its happy place, and so it's going to react in order to get back to that equal dynamic equilibrium back where it's making products and reacting to the same rate. So you're going to use this I information and you're going to find Q, which is called the reaction quotient. The reaction quotient is basically like your GPS trying to find out where in the heck you are. And the way you solve it is just like you solve for K. We're going to be putting the products over the reactants raised to their coefficient power. But instead of at E is how we calculate the K. We use that information. For Q, you use this information. Works the same way. But Q's just going to let us know, are we there yet? Okay, so we're going to go 0.790 molar. And we're going to raise it to its coefficient power, which is 2, divided by 0.08, raised to the first, times 0.06 raised to the first. And when you put that in your calculator, you find your reaction quotient, trying to figure out where we are, is 130. So let's think about this. If you were at 130, house number 130, and your friend lives at house number 50, do you need to go forward or do you need to go backwards? Think of on a number line. You're at 130. Do you need to go back or forward? So you're at 130. Q is your quotient where you're at. So you need to go backwards, which means you need to reverse. What reverse means in a reaction? It means you're making reactants and we're losing products. That's called a reverse reaction. Reverse reaction means you're going this direction. You're making reactants. Does that make sense? Okay, so we're making reactants. So basically I did all that work just to say the reaction is going to go that direction to figure out this. So now I don't know how much, but I'm going to let that be X. That X, look at this guy. He's got a 2. So he's going to be a 2X. So then 0.08 plus X, 0.06 plus X, 0.790 minus 2X. Oh my goodness gracious. Now, products over reactants, 0.790 minus 2X. Parentheses around that whole thing, square is on the outside of that parentheses, divided by 0.08 plus X to the first and 0.06 plus X to the first equals the K, which was 50. We're going to get ready to put that into the solver, so we're going to subtract 50 from both sides to set this guy equal to 0. So we get ready and put it in the solver, and we're going to need a double set of parentheses around the guy on the bottom, because the bottom's a little special. The top doesn't ever need it. The bottom's going to need that double set of parentheses around the whole thing. All right. Once we use that solver, I'm going to go to the calculator, but I'm going to go ahead and put our values in here. You're going to find the X to be 0.0329. That's not the answers that I've given to any. Why? Because this is 0.08 plus X, so you have to add X to that, and 0.06 plus X, so you have to add X to that, and this is 0.790 minus 2X, so that's how you're going to get those values. So this one's a little bit harder because it teaches you how to use the reaction quotient, but you're also having to use the solver, and you're having to pay attention to the power. So this one's got a lot of good meat to it. So let's go to the calculator and see if we can put it in the calculator.
Okay, so let's try this next example. Remember how we start? We go 0 stow X. That clears out the calculator. We're going to go math, and then I go math up and hit enter. And then you've got all that previous one in there, so just hit the arrow up and hit clear. It'll clear it all out for you. And so this one we need a parentheses around that 0.790 minus 2X. We need to close that parenthesis, and then that whole thing is squared. That's very important to close that parenthesis, and that whole thing is squared, divided by, now we need that double set of parentheses, 0.08 plus X, close that parenthesis, and then 0.06 plus X, close that parenthesis, close the other one, and now we need to take something to get rid of that K, so minus 50. Then you hit enter, then alpha enter. So it's enter, then alpha enter, and there's that 0.0329 that I said we would get. So I'm going to hit second quit, and now I could go 0.08 plus X to get the value. So I get 0.113 for the H2, 0.06 plus X, and so I get 0.0929, and then I get 0.70 minus 2X, and like we get the HI to be 0.724. So there's the solver. It's going to take some practice.